Hello everyone, my name is Haris Kaitazovich, and I am presenting my paper on developing virtual simulation of Optic Lab in physics education using virtual reality. Let's get into the introduction. Developing technologies such as virtual reality have the potential to enhance aspects of our life, such as education. One way VR is able to enhance education is through educational VR applications, as they can offer more accessibility, more availability, and potentially a new way to explore topics in education. There has been research done showing that students are intrigued in the idea of VR application. Students want VR applications for various STEM topics. One study also suggests that lab equipment can be quite expensive, and with VR technology becoming cheaper, it may become a viable alternative given there are sufficient amounts of educational VR applications. And that brought us to our problem statement where there is a lack of educational curriculum aligned content in virtual reality. After speaking with a few professors at my university, there was an idea in making a educational VR application focused on physics. Since the study initially started as a capstone project, the topic of the application focused towards optics, mainly the laws of reflection and refraction. Throughout the development of the project, three activities were made, where each activity contained an interactive blackboard and a puzzle-based scenario. A pilot study was also conducted at the end of the development phase. Now on to the related works. A few of the papers we read found that students are interested, motivated, and wanted educational VR experiences in their learning. Educational VR applications and collaborations with educators ensured accuracy and relevance to their curriculum. Cognitive processing, attention, engagement, and critical thinking produced in a VR environment were more significant and on par with traditional teaching methods. Immersive environments significantly improve students' understanding of complex concepts, and learning theories such as constructivism, scaffolding have been applied to educational VR applications in the past. Now, on to the research method. The development of this project, as stated before, started as a capstone project. Discussions with a physics professor and VR project supervisor helped create the idea for an optics application. The development of the application was done in three phases. Phase 1 included setting up version control, learning Unity VR development, and simulating light reflection and refraction. As you can see from the pictures on the right, the simulation of light was done through Unity's line renderer component. Fortunately, the line renderer had a function for reflecting the line. However, to get refraction to occur, it took some scripting with some vector math. Now, phase 2 mainly focused on user experience and accessibility. We added movement options such as teleportation and snap turning. We added voice narration to the text, and we improved and finished the core mechanic to ensure there's no bugs to occur when experiencing or when reflecting or refracting the light. Phase 3 included polishing and bug fixing, and in the testing phase, we got participants into the immersive educational VR experience, and once they completed it, they answered a short survey at the end. So if you were a participant, this is what you would have seen. Here on the screen right now is just the tutorial area. Participants were given some time to explore, get used to the VR controls, as well as get familiarized with some objects they'll interact with, like the cube and mirror, as you can see, as well as the blackboard, where most of the learning and talking, well, voice narration would come from the blackboard. Now on the left, you can see a user going through the blackboard, learning about reflection, and they hit the next to go to the next slide, previous to go back. No matter what, as long as they don't hit the done, the voice narration would start. And on the right, you can see the button being pushed, which would actually start the line renderer, or a light in this case, so that the user can interact with it. On the left, you can see the user grabbing mirrors and reflecting the light. And on the right, you can see a user taking the refractive cube and actually bending the light to go up or down. Now on to the testing results. A total of 3 questions were asked during the post pilot study survey. The pilot study had a total of 6 participants. The first question asked how well was the simulation of the law of refraction demonstrated. We asked this question as it was the more difficult law to understand. The results we got are very promising, as we mostly got 5 out of 5. The second question asked how easy was it to navigate the environment? About half of the individuals were new to VR, and the results we got were also very promising. Having the tutorial definitely helped with improving user experience with navigating the world as they were given time to learn all the controls and the objects they can interact with. Third question asked if the VR application helped the user understand the contents presented. We asked this question as all of the participants were students in my university and have had experience learning through conventional methods such as lectures and textbooks. On to the discussion. All 3 questions showed promising results. The pilot study's results further reinforced the prospect of using VR technology in education as the concepts explored seemed to be demonstrated well. The inclusion of accessibility features and tutorial not only improved the navigation of the environment, but also allows for a wider range of individuals to participate in the application. Although the results were good from the test, some participants suffered from motion sickness when they were closer to completing the third activity. On to the future work. Since this project initially started as a capstone project, we had major limitations on time and the scale of the project as we had 4 months to complete it. But we came up with various ideas that could be worked on in a different, larger scale research project. Some of those ideas were exploring other topics in physics, such as kinematics, or creating educational VR applications for biology, chemistry, psychology, statistics, or any other STEM subjects. We also thought of creating a repository of educational VR content spanning various subjects. And we also thought of conducting a larger scale study with more participants and included more questions. However, this is currently being done by me and the project supervisor. And lastly, we thought of conducting a study with 2 different groups where one goes through a conventional teaching method like lectures and textbooks, and the other group goes through educational VR application and then comparing the results from the 2 groups. Now, on to the conclusion. This study further encourages the idea of VR supporting education. As a recap from the data collected, individuals were able to explore and understand the topic of optics as well as easily navigate through the environment. The pilot testing reinforces the value of VR as an innovative teaching tool, and most importantly, there is an ever growing need for VR researchers and developers. I just want to give a big thank you to the 2 physics domain experts that ensured content accuracy during development. And thank you for listening to my presentation. If you wish to get in contact or have any questions, my email is on screen. Thank you again and enjoy the rest of the conference.